Good day, everyone. Today I am so excited to share to you the lesson 8, Solving Rational Inequalities. The objective of this video lesson, we are going to solve rational inequalities. Let's have this vocabulary list. First, we have the least common denominator or the LCD. The least common multiple of the denominator or the product of the highest power of its prime factor appearing in the denominator. Then we have the solution set. It is a set of values that makes an inequality true. And the last one, we have these critical values. These are the values of x that which render the numerator and the denominator equal to 0. Let's have the steps in solving rational equations. Okay, first, write the inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. Second, find the critical numbers. These are the values of x which make the numerator and the denominator equal to 0. Third, partition the x-axis into intervals based on the critical numbers. Then, pick a test point in each interval. Evaluate the numerator and the denominator and perform a sign analysis. And the last one, of course, write the solution set. Example number 1, solve the inequality 4 over x plus 2 is greater than or equal to 2. Okay, as step 1, write the inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. Okay, how will you do this? So 4 over x plus 2 is greater than or equal to 2. Okay, so we are going to equate to 0 the inequality. So we are going to transpose 2 to other side. So 2 becomes negative 2. So we have here 4 over x plus 2 minus 2 is greater than or equal to 0. Okay, then of course we are going to find the LCD or the least common denominators. So the denominators have x plus 2 and 1 here. So what will be the LCD or the least common denominator? Yes, we have x plus 2. So x plus 2 divided x plus 2 is 1 times 4. We have here 4. So x plus 2 divided 1 here is x plus 2 times 2. Okay, so we have times 2. We have negative 2 times x plus 2 is greater than or equal to 0. Then simplify it. So 4 minus, so negative 2 times x, so we have here negative 2x. Negative 2 times positive 2 is negative 4. Okay, then combine like terms. So 4 minus 4 is 0. The remain is negative 2x over x plus 2 is greater than or equal to 0. Okay, so the rational inequality now is in single rational expression on one side of the inequality symbol, this one, and 0 on the other side. Okay, that is step 1. Okay, step 2, find the critical numbers. Okay, so our inequality now is in negative 2x over x plus 2 is greater than or equal to 0. So for numerator, to find the critical number, so the numerator here is negative 2x. Okay, so equate a to 0. So negative 2x equal to 0. Then divide both sides by negative 2. Okay, so cancel out negative 2. So 0 divide negative 2, that is equal to, yes, x is equal to 0. For denominator, so our denominator here is x plus 2. Okay, equate 8 to 0, so x plus 2 is equal to 0. So therefore x is equal to negative 2. So the critical numbers are negative 2 and 0. Okay, step 3. Partition the x-axis into intervals based on the critical numbers. Okay, so we are going to graph critical numbers in the line graph. So negative 2 and 0 is here. So why is it negative 2 is hollow? So hollow because negative 2, if we are going to substitute it to the inequality, so negative 2 plus 2 in the denominator, that is equal to 0. So any number divided by 0 here, we can say that it is undefined. So therefore, negative 2 is hollow here. So negative 2 is not included in the solution set. Then 0 here is shaded. Why shaded? Because if we're going to equate 0 to the inequality, so negative 2 times 0, that is 0 over. So 0 plus 2 is 2. So 0 divided 2 is 0. So 0 is greater than or equal to 0. So, and this is possible that 0 is greater than or equal to 0. Therefore, 0 here is included in the solution set. Therefore, it is shaded. Okay, now we are going to find the intervals. So we have here 3 intervals. From here negative 2 going to the left, and from negative 2 to 0 and 0 to the right. Okay, so what is now the first interval? Yes, it is negative 2 to negative infinity. Okay, so we use parentheses here. So if it is hollow, from point here negative to hollow, so we use parentheses. And also parentheses to negative infinity because we don't know exactly the point of this negative infinity. Okay, next interval is, yes, from negative 2 to 0. Okay, so we use parentheses here in negative 2 because this one is hollow, and we use brace if it is shaded. Okay, so negative 2 to 0. 0 here is, we use brace. Okay, about the third interval, yes, from 0 to positive infinity. So we use brace in 0, while in infinity we use parentheses. Okay, let's have step 4. Pick a test number in each interval and construct a table of signs. Okay, so again, remember that our inequality now is in negative 2x over x plus 2 is greater than or equal to 0. Okay, so we're going to make a table. So in the first column here are the intervals, the test number, then the numerator of our inequality negative 2x, and the denominator x plus 2, and the expression here negative 2x over x plus 2, and the solution set. Okay, in the intervals, so we have here the 3 intervals, negative 2 to negative infinity, then from negative 2 to 0, and from 0 to positive infinity. Then the test number, how will you get this one? So here is negative 3. So any number in between negative 2 to negative infinity. So we use here negative 3. So you can use also any number. So negative 4, negative 5. In between negative 2 to negative infinity. Okay? And next here is negative 1. So from negative 2 to 0. So we use negative 1. Then the interval 0 to positive infinity, we use 10. Okay? Then test now. The numerator. So negative 2x. If x is negative 3, so negative 2 times negative 3 here is positive 6. So substitute negative 3 to variable x here. Negative 2 times negative 3 is positive 6. Okay, therefore here is positive. Okay, next negative 1. So negative 1 times negative 2 times negative 1. Okay, positive 2. So use here is positive. Then 10. Substitute the variable x here. So negative 2 times 10 is negative 20. So this is negative. Okay, next x plus 2. If x is negative 3, so negative 3 plus 2 is negative 1. Okay, negative here. Then if x is negative 1, negative 1 plus 2 is positive 1. Here is positive. Okay, next 10. So 10 plus 2 is 12. So positive here. Okay, next the expression negative 2x over x plus 2. So just divide the numerator by denominator. Okay, so positive divide negative is negative. Okay, positive divide positive is positive. So negative divide positive is negative. Okay, so that's solution set. So what will be our solution set? Okay, here in the inequality, the negative 2x over x plus 2 is greater than or equal to 0. So the inequality here is greater than or equal to. Okay, so what numbers are greater than or equal to 0? Again, what numbers are greater than or equal to 0? Okay, yes, it is positive integers. So here, the answer should be positive. Therefore, our solution set is here. This one. From 0 to negative 2. Okay? Step 5. Write the solution set. Okay, our solution set, we have intervals from negative 2 to 0. Okay, so if we are going to see in the graph, okay, so this one, the yellow one, the yellow. Okay. Example number 2, solve the inequality x plus 3 all over x squared minus 5x plus 4 is less than or equal to 0. So the first step, we are going to write inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. Okay, so here in our inequality, x plus 3 over x squared minus 5x plus 4 is less than or equal to 0. So it is already as a single rational expression on the other side, this one. And of course, 0 on the other side. So no need to change or rewrite the inequality. Okay? Okay, step 2, find the critical numbers. So for the numerator, so the numerator here is x plus 3. So x plus 3 equate a to 0 is equal to 0. So x is equal to negative 3. Okay? Positive 3 transposed to the other side, so it becomes negative. Next, for the denominator, we have here x squared minus 5x plus 4 is equal to 0. Equate a to 0. Then factor out x squared minus 5x plus 4. So this is the factors are x minus 4 and x minus 1 is equal to 0. Therefore, x minus 4 is equal to 0 and x minus 1 is equal to 0. So x here is equal to 4 and x equal to 1. Therefore, the critical numbers are negative 3, 4, and 1. Step 3. Partition the x-axis into intervals based on the critical numbers. Okay, so negative 3 here is here, 1 is here, and 4 is here. So why is it negative 3 is shaded? Why? So negative 3, we get this one, this critical number from numerator. Okay, so negative 3 plus 3 is negative 3 plus 3 is 0. So negative 3 plus 3 is 0 here over real number. So that is equal to 0. And 0 is less than or equal to 0. And this is possible. That 0 is less than or equal to 0. Yes, therefore, negative 3 here is shaded. Meaning to say this is included in the solution set. Next, 1 and 4. So why are they hollowed? So 1 and 4, these critical numbers are from the denominator. We get this one from denominator. So negative 1, if we're going to substitute to, yes, we all know that x squared minus 5x plus 4, the factors are x minus 4 and x minus 1, the denominators. So negative 1, if x is 1, so 1 minus 1 is 0, times this one is 0. So meaning to say real number over 0 here is undefined. So if it is undefined, meaning to say this is hollowed. 1 is not included in the solution set. How about 4? So 4 minus 4 is 0, times this one is 0. So real number over denominator here is 0. No, undefined. Therefore, 4 here is hollow. So what are now the intervals? Okay, so we have 4 intervals. From here, going to the left, from negative 3 to 1, 1 to 4, and 4 going to the right. Okay, so this is negative 3 to negative infinity. So we use brace here because this is shaded to negative infinity parentheses. Then from next, okay, so from negative 3 to 1, so we use brace in negative 3 because this is included in the solution set, and 1. Here is parentheses because 1 is not included in the solution set. Next interval. Okay, 1 and 4. So we use parentheses because 1 and 4 are not included in the solution set. They are hollow. And the last interval from 4 to positive infinity, and we use parentheses. Okay. In step 4, pick a test number in each interval and construct a table of signs. So we have here now the tables. So we have intervals, test points, the numerator x plus 3, the denominator, the square, the quantity of x minus 4 times the quantity of x minus 1. Then we have here now the expression x plus 3 all over the quantity of x minus 4 all times the quantity of x minus 1. Then the solution set. So for the intervals, so we have here the 4 intervals. Yes. The test points for the first interval, we use negative 4 from negative 3 to positive infinity. Next, negative 2. So from negative 3 to 1, we use negative 2. Then from 1 to 4, we use 3. From 4 to positive infinity, we use 7. Then for the numerator, so let's have now the test points. We use the test points. So negative 4. Substitute to variable x. So negative 4 plus 3 is negative 1. So negative here. Then negative 2. Negative 2 plus 3 is 1. Therefore here is positive. Then 3 plus 3. So if x is 3. So 3 plus 3 here is 6, so positive. Then if x is 7, the test point is 7, so 7 plus 3 is 10. Therefore here is positive. For the denominator, so here the test point is negative 4. So negative 4, okay, negative 4 minus 4 is negative 8. Then negative 4 minus 5 is negative 5. So negative 8 times negative 5 is positive 40. Here is positive, okay? Next test point, negative 2. So negative 2 minus 4, here, negative 6. Then negative 2 minus 1 is negative 3. So negative 6 times negative 3 is positive. Here is positive, okay? Next test point is 3. Okay, so 3 minus 4 is negative 1. 3 minus 1 is 2. So negative 1 times positive 2 is negative. Here is negative, okay, negative 2. Okay, negative here. Then, if x is the test point is 7. So 7 minus 4 is 3. Then 7 minus 1 is 6. So 3 times 6 is 18. Positive 18 here. Okay? Then, next, x plus 3 all over the quantity of x minus 4 times the quantity of x minus 1. Okay? So negative divide positive is negative. Then positive divide positive is positive. Positive divide negative is negative. Then positive divide positive is positive. Now, what are the solution set? How will you determine the intervals for the solution set? Okay, let's focus on this one. The inequality here is less than or equal to. So what numbers are less than or equal to 0? Again, what numbers are less than or equal to 0? Is it positive or negative? Yes, it is negative. This one, negative. So meaning to say, these are our solution set. So there are two intervals from negative 3 to negative infinity and from 1 to 4. Next, step 5. Write now the solution set. Okay, so our solution set, we have the union of the two intervals from negative 3 to negative infinity and 1 from 1 to 4. Okay, so if we're going to see here in the line graph, so these are the intervals. This one and this one. Okay, for your activity, solve the inequalities. Okay, for number 1, we have x minus 3 all over x plus 2. Minus 3 is less than 0. For number 2, x over x plus 1 minus 2 is less than or equal to 0. Next, number 3, x plus 5 all over x squared plus 8x plus 7 is greater than 0. Here are the references of these video lessons. Alright. Thank you for watching and God bless everyone.